Some pipe materials fail because they crack. Some corrode until water escapes. But lead created a different kind of failure. The pipe could remain buried, remain pressurized, and continue delivering water while the material itself became the danger. For generations, lead was used to make one of the most important connections in the entire water system, the service line between the water main and the building. It was soft, flexible, easy to shape, and remarkably easy to install. So why did a material that works so well beneath the ground become one of the greatest drinking water challenges in modern infrastructure? In the last episode, we followed water from the public system into homes and buildings through copper. But copper wasn't the first metal trusted with that job. A water service line has to leave the main, cross beneath the ground, work around other utilities, pass through a foundation, and enter the building. That route is rarely perfect. The pipe has to tolerate movement. It may need to bend without breaking, and every additional fitting creates another connection that could potentially leak. Lead seemed almost designed for that challenge. Lead is dense, but it is also extremely workable. It can be bent, shaped, and adjusted without requiring the same number of fittings as a rigid pipe. An installer could take a length of lead, guide it through an uneven route, and create gentle bends instead of building the service line one fitting at a time. It resisted many forms of external deterioration. It could remain underground for decades, and because it was flexible, it could tolerate some ground movement without immediately cracking. From an installation standpoint, lead solved real problems. That is what made it attractive. Think about what that meant. A crew could install one continuous piece of pipe from near the water main toward the building. Fewer fittings, fewer joints, fewer places for the service line to leak. The same softness that made lead easy to install also allowed it to be shaped into curved connections, sometimes called goosenecks or pigtails. For the people installing it, lead wasn't chosen because they wanted dangerous infrastructure. It was chosen because it worked. And that is what makes the story so important. Lead was commonly used for smaller water service lines connecting buildings to public water mains. In many older communities, the public main may be iron, steel, or another material, while the smaller service line leading toward the property was made from lead. But the entire service was not always one material. Part could belong to the utility. Part could belong to the property owner. Sections may have been replaced at different times with copper, plastic, or galvanized pipe. That means one service line can contain several generations of infrastructure. And somewhere between them, a section of lead may still remain. Lead pipe does not have to burst to create a problem. The danger begins when lead from the plumbing material enters the water. That usually happens through corrosion. The water reacts with the pipe, its fittings, or deposits inside the system. Small amounts of lead can dissolve into the water. Particles can also break loose and travel toward the faucet. How much lead enters the water depends on several conditions. Water chemistry, temperature, how long the water remains still, the condition of the pipe, and whether the protective scale inside that pipe has been disturbed. Here's what makes lead different from many other pipe failures. You may not see it, you may not smell it, and you may not taste it. The water can appear clear. The pressure can appear normal. The service line can still perform the mechanical job it was installed to do. But the system can no longer guarantee that the water reaching the customer has remained protected through that final section of pipe. The pipe may still work while the material itself has failed the purpose of the water system. Removing lead sounds simple. Find the pipe, dig it up, replace it. But underground infrastructure is rarely that simple. Records may be incomplete. The service line may cross beneath sidewalks, roads, yards, or buildings. The utility may own one section while the property owner owns another, and the material can change somewhere along the route. A lead section may connect to galvanized pipe that has collected lead deposits inside its corroded surface. That is why identifying the entire service line matters. Replacing only part of the line may leave part of the problem still buried. While systems identify and replace lead service lines, water treatment remains critical. Utilities can adjust water chemistry to reduce how aggressively the water reacts with lead and copper. Corrosion control can help create or maintain a protective layer inside the pipe. That layer can reduce the amount of metal entering the water. But corrosion control does not change what the buried pipe is made from. It manages the risk. It does not remove the material. One of the clearest examples came from Flint, Michigan. In 2014, the city changed its water source, but the new water was introduced without the corrosion control treatment needed to protect the system. The more corrosive water disturbed the protective scale inside lead service lines and other lead-containing plumbing. Lead entered the drinking water even though many of those pipes were still buried, still connected, and still carrying pressure. Flint showed the country that changing the water can change how the pipe behaves, and that corrosion control is not simply about protecting infrastructure. It is also about protecting the people drinking the water. Lead teaches us that infrastructure can outlive the thinking that created it. A pipe installed generations ago can remain beneath the street long after standards change, materials improve, and communities understand the danger differently. The crews who uncover it today did not choose it. The homeowners connected to it may not know it's there, and the utility operating the system may be working from records that are decades old or incomplete. That is why replacing lead is not only a construction project, it is an investigation, a record-keeping project, a public health project, and one of the largest material transitions still happening beneath our communities. Hidden beneath streets, sidewalks, and front yards, lead service lines help deliver water for generations. They bent where rigid pipe could not. They survived movement, they reduced connections, and they completed the final link between the public water system and the people it served. But a pipe can be durable and still be the wrong material. It can remain pressurized and still fail its purpose, because delivering water is only part of the job. The system must also protect it. And eventually, the material that made water service easier became the material communities had to remove. Lead showed us what happens when a material lasts longer than the standards that once accepted it. But the next metal was developed for environments where ordinary steel and other materials could struggle. A metal designed to resist corrosion, maintain strength, and perform where failure is not an option. Stainless steel. And that's where our story continues. Welcome back to Under Pressure, Underground.